All right. These are two questions that I'm going to look at from the quiz that you guys are supposed to take. The first question we're going to look at is number 1. And these are just conceptual ideas. And we're just going to look at these one at a time and decide if these are true statements. Okay. The first one says the diagonals of an isosceles trapezoid bisect each other. Okay. And you're going to wonder if that statement is a true statement. Well, whenever I'm confused or not sure, I draw a picture. Okay. So you have an isosceles trapezoid. If you had a smartboard, obviously this would be a lot easier, but you know what it looks like, so you should probably be able to draw an accurate picture. So you look at this, and you decide, do these diagonals cut each other in half? Well, looking at that, you know they don't. This one looks way longer than this one. Okay, another reason you know they don't is because if they did, that wouldn't be a trapezoid. All right, that would be a parallelogram, and you know parallelograms are never trapezoids. And trapezoids are never parallelograms, right? And a trapezoid has one pair of sides parallel, and a parallelogram has both pairs of opposite sides parallel. Okay, number 2. If a parallelogram has opposite angles that are sub, then it is a rectangle. Okay, so a parallelogram's opposite angles. What do you know about them? Well, again, when I asked you to memorize the properties, this is one thing you should have known, is that if parallelogram, then opposite angles congruent. So if they're congruent, and it told me that they are supplementary as well, what do you know about angles that are congruent and sub? Well, you know, if two angles are congruent and sub, then the theorem we learned is that they are right angles. Well, that means if you got a parallelogram where you have opposite angles or right angles, then you know that that thing actually is a rectangle. So that's a true statement. So 1 was false, 2 is a true statement. 3, so let's move on. So again, if there's any point here, you could pause it and try to rewind and understand what I was saying. But that's 1 and 2. So 2 is correct, 3 is next. Okay, so if the diagonals of a parallelogram are congruent, then it could be a square. Okay, the key word for that sentence is could be. Okay, so the diagonals of a parallelogram, all I know about them is the fact that they bisect each other. So I'm telling you, if they're congruent, that makes that parallelogram specifically a rectangle. Okay? So the parallelogram with diagonals that are bisecting each other and those diagonals are congruent, that makes that shape a rectangle. Okay? Which says it could be a square. That's going to be true. It could be a square. Okay? It doesn't necessarily have to be a square, but it could be a square. I don't know. I know it's at least a rectangle, but it could be a square. So the key word again is could be. Okay. Lastly, a quadrilateral is a parallelogram if the diagonals are bisectors of each other. And that is a true statement as well. Okay, that's one of the main properties of a parallelogram. Diagonals bisect each other. So then I look for the answer with 2, 3, and 4. It's answer D. So that would be the answer to number 1. The other question I wanted to look at with you guys is number 6. Okay, so a quadrilateral PQR has vertices 2, 8, 0, 0, 16, 4, negative 4, and 18, 4. So what I'm going to do first is just put this into the picture. If you look, the scale is by 2s. So I'm going to make sure that I recognize that when I'm putting this in there. So here's the point 2, 8. This is point P. Q is at 0, 0. R is at 16, which is 2, 4, 6, 8, 10, 12, 14, 16, negative 4. And S is at 18, 4. So 18, 4. Okay, so my question is, what is the most descriptive name for this shape? So again, when we do this, we check 2 things. We check the slopes of the sides, and then we check the slopes of the diagonals. And these things tell a story, okay? The slopes of the sides tell you if the opposite sides are parallel. It also tells you if the consecutive sides are perpendicular. The slopes of the diagonals indicate if they are perpendicular. So you're looking at this thing, it looks like it's probably a parallelogram of some sort. So let's try to determine which one it is, okay? So first I'm going to look at the slopes of the sides. So I'm going to look at the slope of PQ first. So PQ has a slope of 8 minus 0 over 2 minus 0, which is 4. Okay, I'm going to look at its opposite side, SR. SR has got a slope of 4 minus negative 4, and over 18 minus 16. So 4 minus negative 4 is 8. Over 2 is 4. So I see that these lines, PQ and SR, are parallel. All right, let's see what the other sides are. So I'm going to look at the slope of PS. So PS has a slope of 8 minus 4 over 2 minus 18. So I got 4 over negative 16, or negative 1/4. Okay, and then QR has a slope of 0 minus negative 4 all over 0 minus 16, which is going to give me 4 over 16, 4 over negative 16, which again is negative 1/4. So you see right now that PS is parallel to QR. So this is at least a parallelogram. And if I put these slopes into the picture, okay, these aren't the lengths of the sides, but those are the slopes of the sides. You see that the consecutive sides have opposite reciprocal slopes. So I know not only that it's a parallelogram, before I even check the slopes of the diagonals, I know that it's at least a rectangle. Okay? So next I'm going to look for the slopes of the diagonals. So I have two diagonals, PR and QS. If these diagonals have opposite reciprocal slopes, you know they're perpendicular. So you know that basically what I have at this point is that it's a rectangle. I'm going to check the diagonals to see if it's something more. Okay? So PR has a slope of 8 minus negative 4 over 2 minus 16. So this is negative 6/7. So if QS has a slope of positive 7/6, I'm in business. I know that that's going to then be a square. It's going to be more specific than a rectangle, more descriptive. So just check that real quick, make sure I did that right. It looks like I did. So QS is going to be 4 minus 0 all over 18 minus 0. So that actually comes out to 2/9, which is not the opposite reciprocal. So the diagonals are not perpendicular. So the most descriptive name for this specific shape was what I found out from the beginning. It's a rectangle. Okay? Again, it's got opposite sides parallel. Consecutive sides have opposite reciprocal slopes. 4 and negative 1/4 are opposite reciprocals, which means I got right angles. Okay? Now I know I got right angles. I got a parallelogram with right angles. I got a rectangle. To determine if that rectangle is a square, you find out that slopes of the diagonals, which in this case are not opposite reciprocals. So there you go.